We're going to look at the odd and even functions from an algebraic perspective. Here's a geometric representation of the curve 4x cubed minus 16x. Now we can see it's odd, okay, because it's symmetrical about the point of origin, rotational symmetry. So let's have a look at the algebra behind proving that thing. And I'm going to use my iPad to do this. And hopefully it works okay. Okay, so to prove something is odd, I have to prove that the function of negative x is equal to the negative function of x. Okay, so that's what I'm trying to prove. So just moving down a bit. Okay, so when I substitute negative x into this equation, the function of negative x equals 4 negative x cubed, well, put that bracket there, cubed, minus 16 minus x. Okay, and that then gives us negative, because negative x cubed is still negative plus 16x, because negative and negative is positive. Okay, so there's the first one. Now if we look at the function of negative f of x, well, that's just negative times the entire statement. Now just be careful about this and put a negative outside the entire bracket here, and that'll just, x, just to make sure you don't, well, basically you don't forget, so you don't forget, just, sorry, I lost my words there, so you don't forget to times the negative x by everything. Okay, so what we get is equals, and again we get negative 4x cubed, and negative 16 by negative becomes positive 16x, which equals, and this is how you finish it, the function of negative x, and therefore, and therefore this thing is odd. Okay, and that's what we found. So let's go straight on to another example, because I don't want to take too long with these videos. Okay, here's another example. You should be able to sketch that, and I won't do that at the moment. Okay, so let's look at the algebra behind this one. I'm just trying to tidy up my page here before I start. Okay, now we want to prove if it's odd, even, or neither. So simply we go through each step and we say the function equals 4x minus 2. Now, if you wanted to, you could have expanded this whole thing and just done it as one single function. However, we'll keep going like this. Now, the negative function of x equals negative outside of 4x brackets okay. Now there's not much to do there, so we'll keep going. And just remember that this thing here, if I just move up here again, this, let me just fix this for you because it's a bit confusing. This is negative, the function. Okay, moving down. So now we've got the function of negative x equals 4 times negative x, brackets, negative x minus 2, negative x plus 3. Now we would probably need to tidy this up a bit to make it neater, and 4 times negative x is negative 4x. But now we've got this bracket here, and it's minus x minus 2, so if I take negative 1 outside of the bracket, I make both those terms there, and that becomes positive. And I'm left with minus x plus 3. Now, you can see that this is not equal to the first thing we worked on, which is negative fx. And it's not equal either to our original function, which is this, which is this one up here. Whoops. Which is this one up here. So it's nothing. It's not equal to negative f of x is not equal to f of x, and negative fx is not equal to f of negative x. None of these things are the same. So we can simply say at that point this function is neither odd or even. And just to finish this video, just very quickly, you should be able to sketch this thing pretty simply, and I will, because if I do this, the factors of our original function are 0, are positive 2, and negative 3. And so you would get a function that looks like this, something like that. By observation, we can see that geometrically it's not an odd function. It's not even either. But if you're asked to prove this algebraically, you would have to do this method here. But if you were just simply asked to prove it was odd, even, or neither, sketching it and then making a geometrical conclusion would be a much better way to go. Anyway, we'll continue with some more examples in another video.